Hey everyone, welcome back. So far we have covered vectors, dequeues, queues, stacks and priority queues. Today we are going to learn about three more containers: set, unordered set and multisets. These three containers are similar to each other but with slight differences. Let's look at what is the set. Set basically is a container that stores unique elements in a sorted order. So basically it only stores the unique elements and in a sorted order. So here you can see we have a unique boxes and the different colors. So basically if we take a numbers, it only stores unique values and in a sorted order. Similarly, unordered set also stores unique but not sorted, so it stores unique but not sorted. And for the multi-set, it stores duplicate and sorted, so it can have a duplicate value itself and they will be arranged in a sorted orders. Let's declare the set. So to declare a set, we will write set, then our data type int, then as. Let's say if I'm going to initialize with this value, internally the set will rearrange them and sort and also remove the duplicate values. If we talk about the unordered set, to declare an unordered set, you have to write unordered underscore set, then our data type, then I will be using US. Then I can write, now this one will keep your data in a unsorted manner, but it will only keep unique values. Similarly for multiset, we will write multiset, then data type, then so it can keep your data in sorted but also can keep duplicate values. Now all the operations related to the sets are similar in these three. Okay, let's look at the operations used in set. Let's take a set. Initially our set is empty. Okay, now I want to add data into the set. So to add data into the set, we will using the function s.insert. This is similar to the push or pushback because they were also adding the data. Similarly, insert is also adding the data in the set, but it is not adding the data at the end. It is just adding the data in your set and it got rearranged. Okay, so let's add another value which is 5. So it will rearrange them and make them 5 10. Then let's insert another value which is 10. This will be ignored because we already have a 10. Similarly, if you have a unordered set, it also follows same operation of insert. Okay, now let's see how we can traverse on the set. In set, we can easily traverse using range based loop. So let's say this is my set 1 2 3 5 6. Okay, now I want to print my whole set. I can easily traverse using our range based loop. Okay, similarly we can also do it on a unordered set as well as on multi-set. Now there is another function in set which is very useful, which is find function. Means let's say if we want to check if our 5 is available in the set or not. Okay, so we will write if s dot find, then we will write a value not equals to s dot end, then we can write cout found. Now what is happening here, our find function is searching the value inside the set and our AND operator is sitting outside the set. So it is saying s dot find 5 not equals to s dot end. Means if the find pointer is not here, means if find is not here, that means it is somewhere inside the set. If it is somewhere inside the set, then we can say we found a value. If our find pointer is at the end, that means it didn't found any value inside the set. That's why it is at the end pointer. Okay, similarly there is another function count which is similar to the if, but we have to write only s dot count and 5. It will return true or false. Okay, this also have a size which will tell what is the size of your set. And if you want to check the first value in the set, you can use begin. If you want to check last value of the set, you can use back itself, similar to the vector. Now if you want to erase a value from the set, you will be using erase function. So we can simply write s dot erase of 5. This will erase 5 from the set. Now there is two more other function in set, which is lower bound and upper bound. these two function only works on a sorted set, means they will only work for a set or multi set. We cannot apply it on a unordered set. So what they will do, let's see, we have a set 1 3 5 7. Okay, this is our set. If we pass a value 3 here, it will return, or it will point my pointer at this value because it found a value. If we pass a value 4 which is not available in the set, so it will point to the value which is greater than equal to this value. So now it will point at the 5. Basically lower bound will point at a value which is greater than x. X means this is our value, and similarly upper bound will always point at a value greater than x. Means if I have a value of 3, 3 is available in the set, right? 3 is available in the set, but it will not point at this value, it will point at the value which is just greater than the value itself. Okay, so if you want to find a value which is greater than equals to x, x are these values. Okay, we can use lower bound. If we want to find a value greater than x, we will be using upper bound. Okay, now try all these examples in a code, then you will be able to understand. Okay, let's remove this and also remove this. Let's first declare our set. Also let's declare our unordered set and multi-set. We are going to use all the data structure, then we will also declare our multi-set. Okay, I'm going to use here ms, then here I'm going to use yes. Okay, now let's first write a, let's insert value in a set as dot insert 4. Let's make a copy 5, therefore then 6. Okay, let's print. Here you can see we insert a 4 5 4 6, then we used a for loop, then let's run it. Here you can see it is printing me a sorted values and unique, because we had a 4 2 times, it ignored one of the 4. Let's change it unordered set. Okay, now let's run it. Okay, we have to change it here also. Now let's run it. Here you can see it is printing me a unordered values, and let's add more values here. Let's add 6 7 9. Let's run it. Here you can see it is printing me a 97654. Okay, in this example you are seeing it is sorting in a descending order, but the order is not guaranteed in every case. Maybe this time it is printing me in a descending order, but you cannot predict what will be the order in, if you are going to try it yourself or if you are using somewhere else. Okay, now let's try multiset also. Let's change here and let's run it. Here you can see it is giving me a sorted plus duplicate values itself. Okay, now let's come back to our set. This is our insert. Okay, now let's use a find function. If s dot find, let's say if I want find a value 5, then we will print found. Okay, let's see what it will print. Here you can see it is printing found. That means this condition is true, means it is able to find a 5 in a set. Let's change it to a random value 9. Now let's run it. Now it is not printing me anything because we haven't tried a else condition. That means it didn't find any value 9 in a set. Similarly, we can use our count function also. For count function we don't have to write and itself, we'll write count, right, 4 this time. Then let's run it. Here you can see it is printing me a found. That means 4 is also available in the set. Now let's add more values, 7 then 8. Now let's remove some values. To remove some values we use erase function. Let's erase our 4 itself, then semicolon. Now let's run it. Here you can see it removed 4 from the set. Let's look what is the value at the first position in a set. Here you can see it is giving me the error matches these operands. Okay, this is saying types are stream standard tree const iterator, means this s dot begin is iterator, means it is giving me the address, not a value. To access a value we have to write here star sign here. Now it is not giving me an error. So if you want to print a first value of a set, you have to write star then as dot begin. Now let's print it. Here you can see it is printing me a 5. Okay, there is no back in a So let's try to print, and okay, there is no back in our set, but it works on and itself. Now let's try lower bound and upper bound. Let's comment it. Let's print the lower bound, right? Dot lower bound, then our value of 4. Let's see what it will print. Okay, here you can see it is giving me an error. It is the same error iterator, so we have to use star here. Okay, let's see what it will print. Here you can see it is printing me the 4. That means it is able to find a 4 in our set. So we have a 4, 5, 7, 8. Let's try with the 6. In this case we don't have a 6 in a set, so let's run it. Now it is giving me the 7. That means it is first finding if equal value is present or not. If equal value is not present, it will look value greater than value itself. Okay, let's try with the upper bound. Now let's see with the 4. We know 4 is available in the set, but upper bound will always give me the greater value, so it will give me a 5 itself, not a 4. Okay, so lower bound will consider greater than equals to, and upper bound will only consider greater values. Okay, now lower bound and upper bound cannot be used on a unordered set. Okay, and you can use on multisets. Okay, and now let's look at the multiset. Here you can see we are using erase here. Okay, so let's first change to the multiset. This is multiset, this is also multiset. Let's comment them, not need. Okay, now if we are using multiset, let's first print it. Here you can see it is printing me 4, 4, 5, 7, 8. Okay, now if I want to erase a 4, I can use erase function. Okay, it should be ms. Here you can see I had 2 4. When I used erase function, it removed all the 4. Means whenever you are using multiset and you want to erase a single value, the erase function will remove all the instances of that value. That means I want to erase only one 4 but remove all the 4s from the set. If I want to erase only one value, I have to write ms dot find then 4. That means it first will find 4, any of the 4, and erase that 4 only, not all of the 4. Okay, so whenever you want to erase single value from the multiset, make sure you first write ms.erase, then inside it you should write ms.find and the value you want to erase it. Now here you can see it is giving me the 4, 5, 7, 8. Okay, similarly the count function, let's comment it. There is a slight use of count function in. Okay, this time we have to print it. Let's run it. Okay, not a semicolon. Here you can see it is giving me the 2. This time the count function is working as a indicator, means how many times that value is in the multiset. Means our 4 was 2 times in a set, so it is giving me the 2. In a set there was always one value, that's why it returning 1, means we are considering it a true. But in this case let's add one more 4 also. This time we have a 1 2 3 and 4 4. So let's run it. Here you can see it is giving me the 4 4, means it is counting how many times that value belongs in that multiset. In set also it was working as a counter, but in set we had one value, so it was returning 1 or a 0. Let's try with value 9 and let's run it. Here you can see it is giving me the 0. That means that value is not available, so we can say it is a false itself. Okay, that's it for the set, unordered set and multiset. All of them are similar with some alteration, means set can store sorted any unique value. Unordered set can store unique but the value will not be sorted. In multiset value will be sorted but with duplicate values. Insert is similar for all of them. Find also similar. Count is little bit different. It will count how many times the values exist, and if we want to check first and last value we will be using begin and here you can use our range based loop, but still you cannot use our standard index based loop. Here you can use lower bound, upper bound. Lower bound and upper bound can be used on set and multiset itself but cannot be used on an unordered set. And here erase function is different for a set and multiset, and in a unordered set there will be going to only one value, so the erase function similar to the set itself. Okay, that's it for the set, multiset and unordered set. Thank you everyone, have a nice day.